All right, so blood mineral homeostasis. Well, when we talk about that, we talk about building strong bone. We talk about either hyaline cartilage or collagen fibers that build osteoid tissue from our bone development lecture. What occurs is osteogenic cells will become osteoblast. Osteoblasts will go into these scaffolds, these molds of cartilage and collagen fibers. They'll start to lay down a matrix called osteoid tissue. When they surround themselves, they'll become osteocytes. When these osteoblasts become osteocytes, like we talked about in that bone development and growth lecture, then they start pulling in calcium phosphate or these hydroxyapatite salts. So to do this, there are 3 hormones that regulate this bone building process and remodeling. The first 2 we're going to talk about do bone resorption, which is going to be calcitriol and parathyroid hormone. So first, let's talk about calcitriol. So this hormone, this is the very strong or potent form of vitamin D3. So whenever we see this, we're going to think vitamin D3. So when we start to look at bone mineral homeostasis and calcium homeostasis within the bone and the blood, we look at vitamin D3 and calcitriol. Now, when we look at this, calcium is important for muscle contractions, for the skeletal muscle, for the heart. It's also important for blood clotting and nerve activity. But then when we look at regulating calcium, not only is it just the bone tissue, but we have to look at hormones, so that's the endocrine system. Calcitriol begins its synthesis in the skin, as well as the liver, then into the kidneys, and then our digestive system. So there are a lot of tissues involved in calcium homeostasis. So calcitriol, we're going to get sunlight will stimulate epidermal cells. And these epidermal cells are keratinocytes. These keratinocytes, when they're stimulated by the sun, we already know keratin is produced, and we talked about that in the integumentary system, but these keratinocytes convert a substance called 7-hydrocholesterol into a substance called pre-vitamin D3. So sunlight is important. 7-hydrocholesterol, this is a molecule built on a cholesterol, which is fat soluble. It's a very strong, potent, or sterol hormone, and it produces pre-vitamin D3. So on here, continual sunlight. So you want to have enough sunlight to stimulate this conversion from 7-hydrocholesterol into pre-vitamin D3. Then continual sunlight converts pre-vitamin D3 into just regular vitamin D3, okay? Our normal vitamin D3 is called cholecalciferol. Once pre-vitamin D3 is converted into cholecalciferol or vitamin D, it is released into the blood. So now we have this in the blood plasma. So it's in our general circulation. Okay. When vitamin D3 hits the blood and gets into our general circulation, so we'll say blood plasma, vitamin D3, it will circulate throughout the body. So blood plasma vitamin D3 is converted in the liver, and it's converted in the liver by putting a hydroxyl group, which is an OH group, onto this vitamin D3 molecule. And it's converted in the liver into a precursor hormone called calcitriol. Calcitriol will now continue throughout the circulation. And then is converted, so calcitriol then travels to the kidneys. Again, in the kidneys, calcitriol has another hydroxyl or OH group added to it, and then it becomes calcitriol. So calcitriol then travels to the kidneys and is converted into calcitriol. This is our strong, potent form of vitamin D3. Okay. So, got to have decent sun exposure, not too much, but just enough to stimulate keratinocytes to convert 7-hydrocholesterol into pre-vitamin D3, and then enough for that pre-vitamin D3 to become regular good old vitamin D3 or cholecalciferol. And then it can go into our blood circulation and be converted through the liver and the kidneys. And that's very important. Now let's talk about the functions real quick to finish up our talk about calcitriol. So calcitriol functions. Now, the main function here that we need to talk about is bone resorption, or we'll say bone calcium resorption. Meaning we, let's say this is breaking down bone to release calcium into the blood. So as a result, this will increase blood calcium levels. And that's how it does it. Now it does this in a few ways. The first way it does this is to increase the osteogenic cells into osteoclasts. Now, this increases osteoclastic activity. Now, osteoclastic activity is to break down bone tissue, which is called bone resorption, right? Releasing calcium that is stored in the bone into the blood, therefore increasing blood calcium levels. So the general point of what we're trying to get here has already been stated. These are just the ways that it does it. Now, the other thing that it will do is it will increase absorption of calcium in the small intestine. So if you consume calcium in your diet, calcitriol helps increase the absorption of calcium into the diet, so that way you can get more absorbed from your intestines into the bloodstream. Again, this increases blood calcium levels. The next thing that it does, and the third and final thing, is it will increase reabsorption of calcium in the kidneys. Therefore, we do not urinate calcium out and excrete it from our body. That way, the kidneys will reabsorb it, keeping more calcium in the blood, because the blood is filtered through the kidneys. Toxins are taken out, those toxins are removed in urine, but then if we increase the reabsorption of calcium in the kidneys, we keep more of that calcium into our blood. So increasing osteogenic cells in the osteoclast, which increase osteoclastic activity, which is bone resorption and breakdown, releases calcium from the bones that is stored into the blood and increases blood calcium levels. Increasing the absorption of calcium through the small intestine in our diet, and then increasing the calcium reabsorption in the kidneys. All three of these processes are how calcitriol function to elevate blood calcium levels.